Assalamu alaikum students. First MCQ is electrostatic is the branch of physics which deals with charges in motion, at rest, both motion and rest, at rest. Here option C is correct. Okay. Electro mean charges and statics mean at rest. So option C is correct here. The quantization of charge means that charge exists in the form of discrete packet. Okay. Quantization means a charge must be in a whole number like 1, 2, 3, 4 and 5, and it must not be half, 2/3 or etc. A charge must be in a whole number. So quantization of charge means the form of discrete packet. When a neutral body is rubbed and it becomes positively charged, it must lost electron. Okay. When a body gain positive charge, it means that electron is lost. When a body gain negative charge, it means that it gain electron. So the positive and negative charges are due to the loss and gain of electron, not the proton. Okay, here option C is correct. According to classical electrodynamics, the minimum charge on a body is, now look at here, the minimum charge must be 1 electron. Okay, now look at here, this is 1 over 2 electron. And we have studied that a charge must be quantized. It must be in a whole number. And look at here, this is half. It is not a whole number. So it means that this one is incorrect. Option C is incorrect. And here the minimum is 1 electron. Okay. So a charge must be 1, 2, 3, 4, 5 in whole number. So the minimum is 1. Okay. Next one. If the product of two stationary charges is negative, then the coulomb force is, now look at here, we know that the product is negative in that case when the charge, one charge is positive and another charge is negative. We know that when we multiply plus and minus, so it will give negative, okay. So it means that these two will be attractive. The coulomb force between them will be attractive. Okay. Now we have to find the direction of force. Now look at here. If we consider this one as a source charge, okay, if we consider this one as a source charge, this charge will tend to attract this one. Okay, this charge will tend to attract this one, and it will apply the force in that direction. Okay, the direction of force will be like this. So if I place another force here, another charge negative, then the direction of force will be like this. Look, it is towards the source charge. Okay, in case of attractive, the direction of force is towards the source charge. Now let's consider the negative as a source charge. Let's suppose it's plus and this one is negative charge. Now this negative charge will also tend to attract this positive charge. So the direction of force will be like this. If we consider this one as a source charge, this one is a source charge. Okay, so this source charge will tend to attract this one towards itself. So the direction of force will be like this. Okay, towards the source charge. So look at the options. Look, the product of stationary charges is negative. It means that it must be attractive and directed toward the source charge. So here option B is correct. Okay, the coulomb force is attractive and it is directed toward the source charge. Now let's find the direction of coulomb force when this one, the product is positive. Here the product is positive. Let's find the direction for that one. Now let's suppose for the product to be positive, the product of two charges to be positive. So let's take two positive charges, plus plus. When we multiply these two, it will give positive. Okay, now this, let's suppose this one is a source charge. Okay, let's suppose this is source charge. Now this charge will tend to repel this one. Okay, this one will tend to repel this one. Now the direction will be like this. Okay, this one will tend to repel this. So look at here, the direction is away from the source charge. Okay, the direction of coulomb force is away from the source charge. Now let's do this for negative. We know that when we multiply two negative charges, it will give positive product. Okay, now let's consider this one as a source charge. Okay, so this source charge will tend to repel this one. Okay, when it repel this one, the direction will be like this. The direction of force will be like this. So look at here, the direction of Coulomb force is away from the source charge. Okay, it is away from the source charge. Now keep one thing in your mind, that do not mix the direction of these forces with electric field. Okay, electric field is something else and these directions are something else. Okay, do not confuse in this. So the conclusion is that if the product of two stationary charges is negative, then the Coulomb force will be attractive and directed toward the source charge. If the product of two stationary charges is positive, then the Coulomb force will be repulsive and directed away from the source charge. Okay, it will be repulsive and directed away from the source charge in case of positive product. Okay, but here option B is correct. Next one. 6. The Coulomb's force between two charges Q1 and Q2 separated by a distance r and is F if the separation between two charges is doubled. Keeping charges constant, then the Coulomb's force become. Now the required is that what will be the Coulomb force if the separation becomes double. Now look at here, we know that Coulomb force is equal to K Q1 Q2 divided by R square. Now if we keep all these constant, okay, then Coulomb force will be directly inversely proportional to the R square. Okay, and here in question the required is that what will be the Coulomb force if the separation is double. Now 2R. Okay, so it will give nu F will be inversely proportional to 4 times of the R square. Okay, now if we put these constant, okay, here, so it will become nu F will be K Q1 Q2 divided by 4R square. Now look at here, we know that this one is equal to F. Okay, now put F here in place of this, so nu F will be 4 F divided by 4. Okay, 1/4 of the original force. When the separation become doubles, the new Coulomb force will be 1/4 of the original force. Now look at the options. Look here, option B is correct. Okay, next. The Coulomb force between two charges Q1 and Q2 is separated by a distance 5 cm is 8 times. Okay, if the separation between them is 10 cm, sorry, then the force become. Now look at here, the separation is doubled. Look, it's 5 and this one is 10. Now the required is that if the separation becomes double, then what will be the Coulomb force? Look, we can consider it as double. Okay, now from the last MCQ we have found out that if the separation becomes double, then the new force will be 4 times of the original force. Okay, now if I put here 8 dynes divided by 4, then it will be 2 dynes. Okay, the answer will be 2 dynes. Here option C is correct. Look, you can find out by doing this calculation. The original force is 8 dynes, which is also equal to Q1 Q2 divided by R square. The new force is Q1 Q2 divided by 2 times. The separation has become doubled. Okay, from 5 cm to 10 cm. It means that it has become doubled. Now new force will be 4R square, Q1 Q2 divided by 4R square. Now in place of these, if I put here 8 dynes, okay, we know that this one is same. Okay, and in place of this I can put 8 dynes, so 8 divided by 4, you will get new force will be 2 dynes. Okay, you can find it out like this. The Coulomb's force between two charges in air is 80 Newton. What will be the force between them when kept in water? Now in vacuum the Coulomb force is 80 Newton. If we kept it in water, then what will be the force between them? Now look at here, we know that force in medium is equal to force in vacuum divided by relative permittivity, and relative permittivity for water is 80. Okay, and the given Coulomb force is 80 Newton in vacuum. Okay, so the relative permittivity is 80. If we divide this, we will get 1 Newton. Okay, the Coulomb force in water will be 1 Newton. Look at here, option A is correct. Okay, 1 Newton. The Coulomb force between two charges is F if the magnitude of charges are doubled and the separation between the charges is also double. The magnitude of each charge is double and the separation is also double. Then the percent change in Coulomb force is. Now look at here. We know that Coulomb force is Q1 Q2 divided by R square, and the new force when the magnitude of each charge is double, 2Q1 2Q2 divided by when the separation is also double, so it will become like this. Look, new force is 4 Q1 Q2 divided by 4R square. Okay, 2 2s are 4. Now they will cancel each other, 4, so it will be new force will be Q1 Q2 divided by R square. Now look at here, this one is equal to F. Okay, now put this F here. Okay, so if you want to find the percent change, then the percent change will be 1F new force minus original force divided by original force. So this one will give 0. Okay, 1 minus 1 0, and 0 divided by 1 will be 0. Now if you multiply this with 100%, so the answer will be 0%. The percent change is 0%. Okay, look, you don't need to do this calculation. Okay, here the force is equal to new force is equal to original force, so it means that the percent change is 0%. Okay, the percent change here is 0%, so the answer is option C, 0% change occur. The Coulomb's force between two charges in the presence of dielectric medium of relative permittivity 20 is 100 Newton. If the dielectric is removed, then the Coulomb force in vacuum. So we have to find the Coulomb force in vacuum. So here is the formula, that F medium is equal to F vacuum divided by relative permittivity. When we do arrangement in this formula, we will get this one. Okay, so the force in medium is 100 Newton and the relative permittivity is 20. When we multiply these two, so 2000 will be the Coulomb force in vacuum. The constant of proportionality in the Coulomb force depend upon. So it depends on two things, medium and the system of unit used. Okay, because we know that K is equal to 1 over 4. K is equal to 1 over 4 pi epsilon naught. So this one says that it depends on the medium, and it also depends upon the system of unit used. Okay, so here option C is correct. Look, we also know that K is equal to F R square divided by Q square. Okay, so when we change the units of these terms, then the value of K will also be changed. Okay, so it depends on the medium and the system of units used. The dimensions of relative permittivity are known. Okay, we know that relative permittivity is E divided by E naught, so it is the ratio between the same things, so it will cancel the units and the dimension will be none. Look, the ratio is always dimensionless. Okay, the ratio between same quantity is always dimensionless because they are same, so these two will cancel the units of each other, so it will be dimensionless. The electric field intensity due to source charge Q at a distance R from its presence of air. Now look at here, option B is correct. Okay, this one is correct here because it is a electric field is vector quantity, so we have to put the direction here. Okay, and the correct formula is 1 over 4 pi epsilon naught Q divided by R square. Look, here it is R, and here the direction is not given, so option B is correct. Okay, this one formula is correct here. Look at the D option, this one. Look, these two absolute means the magnitude. Okay, when we want to find out the magnitude, so there is no need to put this direction. Okay, so this one is also incorrect. Okay, in case of if we want to find out the magnitude, okay, this one means magnitude, so there is no need to put this direction, so the correct one is this. Electric field intensity is directly proportional to the test charge. No, directly related to the square of the distance from the source charge. Look, D, inversely related to the square of the distance from source charge. We know that electric field intensity is equal to KQ, where Q is the source charge. Okay, KQ divided by R square. This Q is a source charge, so inversely related to the square of the distance from the source charge. When a charge Q is moving perpendicular to the electric field, the force experienced is, now look at here, the force will always be directed along the field, okay? The force will be QE and it will be directed along the field. Look, we know that electric field is equal to F divided by Q and F will be equal to QE, okay? And about the direction, so here is the field lines, okay? And the charge is moving like this, perpendicular, but still the force will be in the direction of the field line, okay? This charge will always experience the force along the field, so option A is correct here. A special type of dry black powder used in a photocopier is toner, okay? The electric flux of electric field through an area A, which is oriented at an angle theta to the field lines is. Now, in case of angle, we use the flux EA cos theta, okay? In case of angle, we use it as cos theta. So here option B is correct. 1 Newton per coulomb is equal to volt per meter. Now look at here. We know that Newton per coulomb is the unit of electric field, which is force per unit charge, okay? And we also know that electric field has another formula, which is negative voltage volt divided by R, okay? So the electric field has two formulas and its unit is Newton per coulomb and also volt per meter. So option B is correct here. You can also find it like this. Look, if we multiply and divide meter on both sides, multiply and divide meter with Newton per coulomb. So look at here, Newton into meter is equal to work divided by coulomb and meter. Now this work per coulomb will be equal to volt into meter, okay? Work per coulomb is equal to volt and meter will be here. So the Newton per coulomb is equal to volt per meter. Electric flux through a closed Gaussian surface enclosing charge Q is a function of charge enclosed by the surface. Look, the electric flux through a closed Gaussian surface always depend upon the charge only, okay? It do not depend upon the size of the surface and shape of the surface. It only depends charge enclosed by the surface. The electric flux through a closed surface enclosing equal and opposite charges is 0, okay? Now look at here, it's a surface and equal and opposite charge mean, let's suppose this one is positive and this one is negative, okay? Now look at here, we know that the flux will enter like this, okay? And it will leave the surface equal 1, 2, 3, 4. 4 field lines will leave the surface because the charge is equal and opposite. Now here the field will be in this direction, okay? We know that there is a condition in which we consider the flux 0, that if the field line entering are equal to the field line leaving the surface, okay? Entering the field line is equal to the field line leaving the surface, then in that case the electric flux through a closed surface will be considered 0. So here option A is correct. The ratio of electric field intensity due to infinite sheet of charges and two parallel oppositely charged sheet. Now we know that in case of infinite sheet the electric flux is this, and in case of parallel opposite plate the electric flux is this one, okay? Now if we find the ratio, then it will be I have named it A and B, okay? So EA divided by EB. Now here we know that for A it is sigma divided by 2 epsilon naught divided by this one, okay? So it will be sigma divided by E naught. Now bring this one here, okay? Here, so this one will cancel this one and it will cancel this one, so the ratio will be 1:2. Now look at the option. The ratio of electric field intensity due to infinite sheet of charge and two parallel oppositely charged is 1:2, okay? Electric potential at a point R away from the source charge is, so here option D is this one formula is correct, okay? Electric potential is KQ divided by R. Now look at here, this one. We know that potential is scalar quantity, so there is no need to put the direction, okay? And these two formula is incorrect here, okay? So the correct one is KQ divided by R. It is scalar, that's why we didn't put the direction here. The negative gradient of electric potential is also called, so it is called electric field divided by R. So it is called electric field. Look at here, option B, electric field intensity. The potential difference between 2 points separated by 50 cm in the field of source charge 500 coulomb is 200 volt. The electric field intensity of the charge is. Now look, we know that electric field intensity is equal to volt into R, okay? Now it's 200, okay? And radius is 50 R is 50 centimeters, so 1, 2, it will be 0.5 meter, okay? 0.5 meter. So if we divide these two, we will get 400 volt per meter. Which one of the following is the unit of energy? So we know that electron volt is the unit of energy. Like we know that volt is equal to energy per coulomb, okay, or electron. So if I bring this electron here, so energy will be electron volt. A particle carrying a charge of 10 electron coulombs fall through a potential difference of 10 volt. The energy required will be, now energy is equal to 10 electron multiplied by 10 volt, okay, so it will be 100 electron volt. Option A is correct here. A unit positive charge experiences a force of 20 Newton when placed in the field of source charge of 100 microcoulomb. The electric field is, now look at here, here is the two formula for electric field. Look, the one is F divided by Q, force per unit positive charge, okay, test charge, and the second is KQ divided by R square. This one is source charge. Now look at here, a source charge is given, but the problem is here the separation is not given, okay, so we have to apply this one formula, okay. So 20 Newton force and a unit positive charge means the charge is 1 coulomb, so the answer will be 20 Newton per coulomb, like 20 divided by 1 coulomb, so it will be 20 Newton per coulomb. Capacitance of parallel plates capacitor is independent of potential difference between the plates of capacitor. Now look at here, the capacitance depend upon the area, medium between the capacitor and separation. Look, the formula is A divided by D and epsilon naught. So it means that it depends upon area, separation and the medium between the capacitor and independent of the potential difference. When the charge on the plate of capacitor is quadruple, then the potential difference between the plates is. Now look at here, we know that Q is equal to CV. Now if the charge on the plate of capacitor is quadruple, if the charge is quadruple, then the potential difference between the plate will be also quadruple. So option B is correct here. The capacitance of parallel plate capacitor having vacuum between the plates is where K is the coulomb constant. Now look here, option B is correct, this one, okay. Look, we know that C is equal to epsilon naught A divided by D, and we also know that K is equal to 1 over 4 pi epsilon naught. If I bring this one here and this K in place of epsilon naught, so it will be like this. Now put this value in place of this epsilon naught, so it will be like 1 over 4 by K A divided by D. So the capacitance will be 1 over 4 pi K A divided by D. Look here, option B is correct. The potential difference between the plates of capacitor is 100 volt when a charge of 100 microcoulomb is stored on the plates of capacitor. Capacitance of a capacitor is, now Q is equal to CV and C is equal to Q divided by V, and the charge is 100 microcoulomb, voltage is 100 volt. So if we divide these two, capacitance will be 1 microfarad, okay, so option A is correct here. The capacitance of a parallel plate capacitor is C. If the area of the plate is triple and the dielectric medium of permittivity is 2 is introduced between the plates, then the capacitance of a capacitor is increased by 500. Now look at here, in case of medium, capacitance is E, permittivity A divided by D, and we can also write this permittivity as epsilon naught and relative permittivity. Now look at here, the new capacitance will be when the relative permittivity of 2 is introduced and the area become triple. Okay, so it will be 2 3s are 6, E naught ER A divided by D. Now look at here, this one is equal to this Cm. Okay, so it will be 6 times of the original capacitance. Okay, the new capacitance will be 6 times of the original capacitance. Now in order to find the percent change, take this 6 and subtract 1 from it and multiply it with 100. So you will get 500% increase. Okay, look, these two are directly proportional to the C, so it means that it will increase by 500%. Look, you can also find the percent change like new value is Cm minus original value, which is Cm divided by Cm multiplied by 100%. Okay, you can also find it with this formula and also with this one. Okay, so the percent change is 500% increase. So option A is correct here. The ratio of C vacuum and C medium is equal to. Now look at here, we know that relative permittivity is equal to C medium divided by C vacuum. Okay, now it is, the required is C vacuum and medium. So if I inverse these two, it will be like 1 over R is equal to C vacuum divided by C medium. So here option B is correct. Okay, this one. The energy per unit volume between plates of capacitor is. Now look, the formula is this one. Okay, energy per unit volume 1 over 2 ER E naught E square. During the discharging of a capacitor at T is equal to RC, the remaining charge on the plate of the capacitor is 37% of the total. Okay, 37% of the total. Look, it is 36.7, and when we round it off, it will become 37% of the total. So here option B is correct. Okay, this one was the last MCQ of electrostatics. Okay, if you have any problem in any MCQ, then write in the comment section. Allah Hafiz.